Okay, man. So now we discuss the phenomena of oscillation. Then only you can understand what is oscillation, so how it is applicable for AC circuit.
Phenomenon of oscillation. Let us consider a circuit containing a capacitor. Let initial Let us consider a circuit containing a capacitor. Let initial
Just a minute.
Circuit containing a capacitor. Let initial consider a circuit containing a capacitor. Let initial charge be Q, connected to an ideal inductor. L, stored electrical energy in the capacitor, UE, is equal to half Q square M by C. Since there is no current in the circuit, energy in the inductor is zero. Total energy of the LC circuit is given by U is equal to UE, is equal to half QM square by C. At T is equal to 0, switch is closed, and the capacitor starts to discharge. Current increases to set up the magnetic field.
Some technical problem, we'll see one more time.
Resonance and application of resonant circuits. Resonance system with natural frequency exhibit the phenomenon of resonance. If such a system is driven by an energy source, the amplitude of oscillation increases. For instance, a swing has a natural frequency of swinging back and forth, but When an external force is applied on it, the amplitude of swinging increases. Consider an RLC circuit with voltage amplitude Vm and frequency omega. Its current amplitude Im would be equal to Vm by Z, that is Vm by root over R square plus Xc plus XL whole
Please mute
square,
yourself.
where Xc is equal to 1 by omega c, and XL is equal to omega L, if the frequency is varied. At omega naught, Xe is equal to XL. Impedance is minimum. Z is equal to root over R square plus 0 square is equal to R. This is called the resonant frequency.
Listen
This is
everyone, one
minimum.
more minute.
Z is equal to root over R square plus 0 square is equal to R.
The impedance formula Z equal to root of R square plus XL minus Xc whole square. Okay, now that both also equal, XL and Xc. So both also equal means you will get 0. So impedance is minimum. So Z equal to R.
This is called the resonant frequency. Xc is equal to XL, or 1 by omega naught C is equal to omega naught L, or omega naught is equal to 1 by root LC. Or omega naught is equal to 1 by root LC. At resonant frequency, the current amplitude is maximum. Im is equal to Vm by R. The graphical representation is as shown. We may observe that Im varies with omega in our LC series circuit. Here, L is equal to 1.00 mH, and C is equal to 1.00 NF. There are two values of resistance. R is equal to 100 ohms. R is equal to 200 ohms. Vm is equal to 100 volts. Omega naught is given by 1 by root LC, which is equal to 1 into 10 to the power of 6 radians per second. At the resonant frequency, the current amplitude is maximum. Im is equal to Vm by R at resonance. Current amplitude for case 1 is twice as that of case 2. Applications of resonance circuits. Resonance circuits are used in radios for tuning. Radio antenna accepts signals from many broadcasting stations. So, the circuit is driven by many frequencies. When we tune the radio, the capacitance of a capacitor is varied, such that the resonant frequency is equal to that of the frequency of the radio signal. This increases the amplitude of the current, and attain the maximum frequency. Note: resonance phenomenon can be observed only in the circuits with LCR. Voltages across L and C cancel each other. Current amplitude is given by Vm by R. Vr is the voltage across R. Sharpness of resonance. The amplitude of the current in the LCR series is given as Im is equal to Vm by root over a square plus of omega L minus 1 by omega C whole square. This value is maximum when omega is equal to omega naught is equal to 1 by root Lc. Maximum value, Im max, is equal to Vm by R. Omega naught is equal to 1 by root Lc. Maximum value, Im max, is equal to Vm by R. For values of omega, except for omega naught, the current amplitude is less than the maximum value. If current amplitude is 1 by root 2 times of maximum value, power dissipated is equal to 1 by 2. By observing omega 1 and omega 2, we can say that omega 1 is equal to omega naught plus delta omega. Omega 2 is equal to omega naught minus delta omega. The difference between them is known as bandwidth, that is, omega 1 minus omega 2 is equal to 2 delta omega. Omega 2 is equal to 2 delta omega.
Just a minute. Listen everyone. The resonance condition of a series LCR circuit. So first of all, we know that what is LCR circuit. So LCR circuit means L is inductance and one capacitor and one resistance. The three are also connected in series with the AC source. So this is the AC source. The formula E is equal to E naught sin omega t. So this is L C R. Now resonance condition of a series LCR circuit. So which condition it will act as a resonance? So when current is maximum, so in this circuit is called as resonance condition of a series LCR circuit. Current is maximum. So I is maximum. So from the formula you know that the relationship between current amplitude and voltage amplitude, I naught formula. I naught it is equal to E naught divided by R. So E naught divided by R will come under LCR Z. That only we can apply that root of R square plus omega L minus 1 by omega C. But XL minus XC it is no. So applying the value omega L minus 1 by omega C power 2. So based on the condition you can understand one thing. The I naught, please note down, I naught becomes 0 current amplitude becomes 0 for omega 2 condition also 0 and omega value up to infinity. Okay, so you will get omega L minus 1 by omega C. It is equal to 0. Omega L minus, that below it is an omega L minus 1 by omega C, it is equal to 0. So I need only the value of omega L equal to 1 by omega C So finally you will get omega square equal to 1 by LC, but I need only omega. Omega equal to 1 by root of LC. This is also important formula. So next one, the impedance formula, it is no. Impedance Z equal root of R square plus omega L minus 1 by omega C divided whole power 2. Now omega L minus omega C, it is equal to 0. Then only Z equal to root of R square. So root of R square means that is Z equal to R for the impedance. The impedance values minimum means the circuit is purely resistive circuit. So R, it is you can imagine it is a purely resistive circuit. C, it is a purely capacitive circuit. L, it is an inductive circuit. So R value impedance is minimum. So in the circuit is purely resistive circuit. So purely resistive circuit means, so what is the base difference? The pi value and V value and I value. Please check it yourself. Purely resistive circuit. What is the condition? Give me reply, ma. So purely resistive circuit means the current and the voltage both also same base. The base value current and the voltage or EMF. So both also same. So the current is maximum, circuit current in the circuit maximum. So current in the circuit maximum. That LCR circuit, in this condition LCR circuit is called resonance condition. So resonance. So one of the famous NEET and JEE coaching center in Kota, Rajasthan. Resonance. Please take a notes. Okay, next one. Related frequency. At current amplitude it is no. So current amplitude means I naught. The current amplitude, it will attain the maximum peak. So it is called as resonant frequency. So current amplitude, it is a peak value, that is a maximum. So it is called as resonance frequency. For the formula, omega r, it is equal to 2 pi fr. So already you know that omega r, resonance, it is equal to 1 by root of Lc. So 2 pi fr, it is equal to 2 pi fr equal to 1 by root of Lc. So I need only the value of fr, frequency value. So frequency equal to 1 by 2 pi root of Lc. So next one, current amplitude they are asking means I naught equal to E naught divided by R for the resonance frequency relevant to current amplitude. Please take a notes. Okay. So next one, some important characteristics of resonant circuit. Okay, first one, for the LCR circuit, the inductance, capacitance and resistance, it is connected in series. For in this circuit, the XL, it is equal to XC. The resistive of inductance and the resistive of capacitance both also equal. So that is the first condition. Then only it is possible for resonant circuit. First case. That formula it is no. You will get Z equal to R. Second one, the resonant frequency, that is FR, that formula only, last formula, 1 by 2 pi root of LC. Third one, based on in this formula, the impedance. So impedance means Z. So impedance is minimum. That means impedance. Please note down Z, that is called as impedance, is minimum. So like the circuit is called as purely resistive circuit. So purely resistive. Three points. Fourth one, the current maximum value. Current maximum value. So you will get E naught divided by R. So current is the maximum. So E naught divided by R. So that is minimum and purely resistive. So LCR circuit XL equal to XC, first condition. Fifth condition, the power dissipated in the circuit maximum. The power. So yesterday only we discussed power factors in LCR circuit. Power dissipated is maximum. Now one more thing, the dissipated power it is unknown. In this power equal to E square RMS divided by capital R. So power dissipated is maximum. The power it is equal to E square RMS divided by R. That power factor, it is unity now. The value is 1. Power factor value 1. Because of the voltage and the current both also same base. Power factor. So definitely in this area one more question it is there. Please note down. Power factor. So power factor means cos phi. The value is 1 because pi value is 0. Why pi value is 0 means current and voltage both also same base. Current and voltage both also same base. You himself remember purely resistive. So purely resistive means current and voltage both also same base.
Sir,
Yes, ma'am.
So third point, purely resistive, it also minimum, sir.
Purely resistive means Z value. Z means impedance. But impedance formula is Z equal to root of R square. Just a second.
Yes, sir, yes, sir.
So Z equal to root of R square plus XL minus XC whole square. So what is the condition here? XL and XC both also equal. So both also equal means it is 0. So you will get Z equal to R square into root. So root in the square cancel means Z equal to R. So it is so that Z is minimum and a purely resistive circuit. Impedance value minimum. That is a purely resistive circuit. R referred resistive.
Yes, sir.
Seventh one. So in this resonance occurs at all values of R. Whether it is a minimum or maximum, it is a point value, decimal or maximum value, all the values it is applicable. All the value of resistance. So all the value of resistance, next one. 8th one. The voltage across R is equal to applied EMF. The voltage across the R means so this is the resistance circuit. So in this resistance circuit, so this is the point A, this is point B. So now we are measuring the V value. So voltage across R, equal to applied EMF. So equal to applied EMF means like this one. So both also it is equal. Applied EMF and R value, it is equal. So write the statement. The voltage across V referred voltage across R. So R is the resistance, is equal to applied EMF. So this is the 8th point. 9th one. The voltage across R is equal to applied EMF. Same thing, the voltage across L and C. So L is inductance and C is the resistance, sorry, capacitance. L and C are equal. So phase difference 180 degree. Phase difference 180. So the resultant is 0. So combined resultant means combined together. So L value, C value equal. The phase difference 180 degree. So 180 degree means one is a 0, another one is a 180. So opposite. The resultant value 0. The voltage across L and C are equal. The phase difference 180 degree. So the resultant value 0. The resultant means combined together. Please take a notes. Okay, next one. The voltage across L and C are very high, maximum value, as compared to applied voltage. So 1 mark question mark, every 1 mark, it is very valuable. So please understand, take a notes properly, refer your book. So like this condition, so V across L and C are very maximum as compared to applied voltage. So in this LCR circuit, used to large magnification of AC voltage. So I need large magnification of AC voltage means, so in this LCR circuit it is possible. So in this LCR circuit, it is called as acceptor circuit. Next, one more point. For example, I am feeding the number of frequency, but it will accept only that particular resonance frequency. So others under it will omit, like that. So accept the circuit means the number of frequencies, different values, number of frequency, it will accept only one frequency for FR. So other value it will reject. The current value is maximum. Okay. So again we'll discuss now. So thank you so much. Again we'll meet next class. Thank you.
Thank you, sir.
Thank you, sir.